Hi everyone, now we will be carrying out document analysis. For an overview, we will be covering basic static analysis using VirusTotal, fingerprinting, and Olive bar. For dynamic analysis, we will be using Ragshot, Process Hacker, Process Monitor, and Apart DNS. We will also go through the document defenses, which refers to how the document prevents detection from the user, as well as the document removal. We will start off with static analysis using VirusTotal. VirusTotal is a free online tool which helps us to analyze files and URLs to identify the malicious content by scanning it with antivirus and website scanners. As you can see here, out of 62 scanners, 39 scanners have identified the document to be malicious. From the results, you can see some keywords such as Trojan, downloader, and VBA, meaning that this document is probably a Trojan wanting to download something and uses VBA, which is a programming language. Moving to the Details tab, we can see the basic properties like the hashes of the file type, and the size of the file. It also shows a list of names, which have the same signature after the hashes are compared. In the Relations tab, we can see that the document has some connections to a domain, URL, and IPS, and it has a dropped file, meaning that this document will try to make some connections to the internet to download a file. Next, we will go to document fingerprinting, which helps to ensure that the document we are analyzing on remains unchanged. Using the HashMyFiles application, multiple hashes have been generated from different algorithms. Comparing the MD5 hash here to the MD5 hash from VirusTotal, we can see that the hashes are identical, meaning that this document has not been modified. This also means that the information produced from VirusTotal is valid, as it is referring to the same document. Now, we will use Olive bar. Olive bar is a tool which detects VBA macros, extracts their code, and identifies patterns like suspicious VBA keywords used. For this, we will be using Remnux. First, we need to change the directory where the document is located. Then, we will type in the command to run Olive bar. As you can see, it managed to identify 3 macro files. From the first file, there is a subroutine calling the document open function. The analysis shows that there is something running when the document is opened. The next file can be seen as an empty macro, so there is nothing much for us to look into. Lastly, Olive bar also extracted a set of code, which might be where all the malicious codes are located. Since the code is unreadable, Olive bar analysis detected that the code might be obfuscated. Using the tools above for static analysis, we managed to identify that this document does contain some code written in VBA, which matches the results from VirusTotal. However, it is heavily obfuscated, so we will need to do dynamic analysis to find out the purpose of this document. Now, we will be carrying out dynamic analysis using Ragshot, Process Hacker, Process Monitor, and Apart DNS. From static analysis, we know that the document is trying to make connections to the internet to download a file. To identify where it is connecting to and what file is being downloaded, we have to carry out dynamic analysis to run tools and capture the behavior of the malicious document. I will first conduct a general dynamic analysis by running the malware without any tools to see if there are any noticeable changes made. I can see the document indicating me to click the Enable Editing button and afterwards the Enable Content button. Upon clicking on the button, I waited for a few minutes to observe if this document attempts to do anything that is noticeable to the user. However, no visible changes were observed and everything remains the same. Thus, I will be using some dynamic analyzing tools to help me to get more details about this document. But before that, I will revert back to the snapshot before the malware was executed. Now that I have reverted back to the clean state, I will start the registry analysis using Ragshot. Rack shot allows us to take two different shots of the registry, one before running the malware and one after. Using these two shots, it will compare to see any changes in the registry. From the general dynamic analysis, we can see that it is safe to open the document as long as we do not click on the buttons and activate the VBA macros embedded. We will first change the output path to our desktop. And then take the first shot. Registry analysis is important because malware need to get permissions to make system level changes, and to do that, they need to make changes to the registry. These changes can include not creating an alert when a critical change has been made so that the user would not suspect that the malware is getting installed to the computer. We will click on the Enable Content button and wait for a few moments for the malware to finish executing. Now, we can go ahead and take the second shot. After the shot is taken, we can compare to view the changes made to the registry. You can see that there are modifications made to the PowerShell hives. When there are external connections, values are added to the Remote Access Service, or in short, RAS. This proves that there are some connections made to the internet to download files. As the macros found are in VBA, there are also keys added to the VBA hives. We can also see some folders added here. Now, I will revert back to a clean state so we can use other tools to analyze this document. Next, we will carry out process analysis. We will start the process hacker and process monitor applications, as well as the document. After clicking on the button, we can see that there is a PowerShell.exe running in Process Hacker, meaning that there is an executable file running. However, these processes are killed after a while. In Process Monitor, by pressing Ctrl T, the process tree window is generated. We can see that there is a PowerShell.exe process, and in the command line, we can see the command used to execute the PowerShell process. -w hidden is the command which makes the windows hidden. This is the reason why we did not see any pop-up screen when the PowerShell was executing. -en means that the strings are encoded. Since the strings are in uppercase and lowercase alphabets, we can assume that it is encoded in base 64. We will copy the code from here. Now, we will go to our host machine and open up CyberChef. CyberChef is an online base 64 decoder, and we will paste the string of code here. We will add from base 64 to our recipe panel. We can see that there are some strings containing HTTP. To tidy the output a little, we will try to remove the full stops in between. From the operations panel, we will type in null to remove the null bytes. We can see that each URL starts with an asterisk, so we will search for split. And change the split delimiter to asterisk. The new lines are being split with semicolons. So we will add another split and change it to semicolon. We will copy the code and go back to the virtual machine. We will create a Notepad++ file and name it as output. Then you will paste the code here. The words with the $sign are variables that are being declared. By clicking on the variable on line 2, we can see that it is being referenced on line 4. We will change the variable to 267.exe and remove the plus sign. This env variable is the environment and it is referenced to the user profile. This means that the 267.exe will be downloaded to the user profile. On line 6, we can see that the variable is being referenced to line 14. We will tidy up the code a little by removing the plus signs. And replacing the variable with the content. We can see that the variables storing the URLs are in a for each loop. We will tidy up the code on line 14 to make it more readable. And replace the variables with 267.exe. Same goes to line 16. And remove the plus signs. On line 14, we can guess that for each URL, try to create a web client and download file 267.exe. Moving to line 16, there is an if statement implementing that if it gets an item 267.exe and the length of the file is greater or equals to 25859, start the process for 267.exe. Now we will move on to Process Monitor. Process Monitor has a filter tool that can help us to filter out processes. We will navigate to Process Name and choose PowerShell. And add the process. Next, we will choose Operation and since we know there's connection to the internet, we will select TCP receive. And apply the filters. From the results, you can see that there are indeed connections made to the internet, as you can see the HTTP and HTTPS. However, these IP addresses are unfamiliar to us. You can assume that it is connecting to the URLs we found earlier. Now, we will go back to Filter and remove the operation and see if there are any other information. We will scroll to find if there are any processes related to 267.exe which we found earlier. And yup, you can see that the 267.exe is indeed installed into the user profile, which is called MATT 2020. Lastly, we will move on to do network analysis using apart DNS. We have restored back the virtual machine to a clean state to perform this analysis. First, we will open up apart DNS. Apart DNS will help to inspect any connections that have been made to the internet. We will set the DNS reply IP address to 127.0.0.1 so that any external traffic will be routed back to apart DNS. This is to check if there are any other connections made apart from the 5 URLs we found earlier. Then we will start the server and open the document. After opening the document, nothing malicious has been found, so we will click on Enable Content button and wait for the response. From the results, we can identify that the connections made to the 5 URLs are identical to the 5 URLs we found previously. Therefore, we can conclude that this document acts as a dropper malware. After carrying out dynamic analysis, we managed to determine the purpose of this document from the results obtained. We were unable to get much information by just running the malware, but with the help of the dynamic analysis tools, they managed to capture the behavior of the malware, and it has allowed us to get a better understanding of how the malware functions. Regshot has helped to record the changes made to the registry, which shows that the malware made some connections to the internet. From Process Monitor, we got to know that the malware used PowerShell to run the codes and managed to extract out the command used to run PowerShell. The command used made the console window hidden, so that the user would not know that it is downloading a malware. We have come to the end of the analysis process for this document. To give an overview, we have done static and dynamic analysis on the document. From the results, we can determine the type of malware, the execution, and the functionality of the malware. So let's have a recap of everything we have done. Firstly, we uploaded the document to VirusTotal, and we have identified that this document is malicious, as identified from the 39 scanners. This graph shows more in depth about the document. The one in the middle is the document that we uploaded. As you can see, it branches out to the executable file here, and this signs means that it is a dropper. We can also see it contacting other URLs which we found earlier in the dynamic analysis. Next, we use bar to get the macros embedded in the document. There are 3 macro files identified. 2 of them contain malicious code, and 1 of them being an empty code. However, they are heavily obfuscated, and we were unable to determine what the macros are doing. Moving on to dynamic analysis, we use Regshot to get the changes made in the registry. We can see that Regshot has identified that there are values added into this registry, which is related to remote access service, and there is a PowerShell in front of it, meaning that the connections have been made via the PowerShell. There are also keys added to VBA. As the macros found in this document are in VBA, this registry have to be modified to run the malicious code. Clicking on Enable Content button has resulted in the creation of these keys. There are also 2 folders created after running the malware. Now, to process analysis, there are multiple processes created after we click on the Enable Content button in the document. We saw that a PowerShell.exe was running. However, these processes were killed in less than a minute after being initiated. We went to process 3 to get the PowerShell.exe process. We managed to get the command used to run the PowerShell. -w hidden was the reason why we did not see any pop-up screen running when the PowerShell was executing. -en meant that the strings are encoded. We moved on to decode the strings from base 64 using an online tool called CyberChef. After decoding, we managed to determine what the command was doing. There was an executable file called 267.exe downloaded to the user profile. There were also multiple links found in the code. In summary, the code is trying to download the 267.exe from the links and start the executable file. From Process Monitor, we use the filter function to filter out specific processes. We managed to find out that the executable file 267.exe is indeed downloaded to the user profile and is doing some sort of activity to the system. Lastly, we used apart DNS to identify any connections made to the internet. From the results, we got to know that there are connections made to 5 URLs, and they are identical to the URLs found earlier. All in all, we can conclude this malicious document can be considered as a dropper malware. This is because the document is used as a disguise to install the malware into the computer system. The malware uses some sort of social engineering tactics by appearing harmless to the user. It requires some user intervention for the macros to execute. By executing the macros, then only can the system connect to the internet to download the malware and start executing it. As for the functionalities of this document, it wants the user to think that there is important information there, and for them to get to that information, they will need to click on the buttons mentioned. Unsuspecting users will click it, and if nothing happens, they will move on to exit the application, not knowing that there is a malware getting downloaded. It is harmless if the user does not click on any of the buttons. But once the buttons are clicked, it will attempt to make connections to external websites and download a file called 267.exe. Thus, this malicious document is disguised as a dropper to download a malware from the internet. For the document defenses, the first line of defense is being able to attach itself to an XML file. After unzipping the folder, only a Word document can be found. These attacks are known as Trojan, as the user would not know of its existence, and the malware will then be installed on the user's computer. Another form of defense is to hide its real intention. When the user first opens the document, the image shown is disguised as a harmless image, requesting the user to click on the buttons mentioned. This would make the user want to go ahead and click the buttons, being unaware of the attack. The most secure way to remove the malicious document is to install an antivirus software. These softwares can identify if the document is malicious and prevents them from downloading. As such, the malware will not even enter the computer system. Another way to remove the malware is to do it manually. To do so, users should delete the original malicious document. Next, from the File Explorer, navigate to C Drive, User, Username for us is MATT 2020, App Data, Local, Temp, and delete the VBE folder. Going back to App Data, we will go to Roaming, Microsoft, and delete the Forms folder. Then, we will navigate to the regedit and delete the registry keys identified in regshot. So we'll go to Local Machine, Software, Microsoft, scroll down to Tracing, and as you can see, these two keys are created by the malware. So we will remove it. Next, we will delete the keys that enable the computer to run VBA code. So to do that, we will navigate to Current Users, software to Microsoft and then delete the VBA key. After all this, the traces of the malicious document will be removed. However, it would be safer to have an antivirus installed, as it will constantly scan for malicious files. By removing it manually, users might be prone to missing out certain files or folders or the registry keys, and this can cause damage to the system.